This section of notes entitled, What's the Weather Today? We'll look at the different layers of the atmosphere and the pressure and temperature changes that exist in each layer of the atmosphere. At the end of this section of notes, you should be able to identify the layers of the atmosphere and their physical characteristics. You should also be able to use page 14 of the Earth Science reference table to help you determine the temperature changes and pressure changes that exist at each layer. The atmosphere is the layer of gases that surround the Earth. As you move further into space, the atmosphere thins out to the point where it's almost not detected. So at the surface of the Earth, you have a thicker atmosphere. And then when you're at the farther edges of the Earth, it is a thinner atmosphere. So earlier in this unit, we've talked about air pressure, and that air pressure is measured using a barometer, and air pressure is simply the weight of the air above. And so how does air pressure change with altitude? Okay. Page 14 of the Earth Science reference table has a graph that shows the relationship between air pressure and altitude. It is known as an inverse relationship. As you can see from this graph here, when the altitude is high, the air pressure is low. Okay? So if you increase air pressure when there is a decrease in the altitude. So at sea level, you have the greatest air pressure. Normally it's about 1 atmosphere pressure. You don't feel this pressure on a normal day-to-day basis because the air is pushing all around you. The air inside of your body pushing outward is the same pressure as the air inside of your body, outside of your body pushing in. But this explains why when you go into an airplane, you are flying at higher altitudes and then your ears begin to pop because the pressure inside of your body is now greater than the pressure outside of your body. Page 14 of the Earth Science reference table also explains the relationship between temperature changes in the layers of the atmosphere. Unlike pressure, it is not just one relationship. Temperature changes vary depending on which layer of the atmosphere you are in. So this graph right here is a picture of the Earth Science reference table, page 14. And it shows the temperature and pressure. So as you can see on the graph, temperature is not just a perfect straight line relationship. When you are in the troposphere, for instance, the temperature is higher at a lower altitude. So here, temperature is 15 degrees when you are at sea level, and then the temperature gets to be a negative temperature reading as you increase in altitude. So here it's a higher altitude but lower temperature. Then when you get to the stratosphere, the opposite is happening. The temperature is increases as you go up in altitude. Then the mesosphere is similar to the troposphere. And then this graph right here shows the relationship between pressure and altitude. The next section of slides are going to go through each of the layers of the atmosphere and the general characteristics of each. The most important thing that you will need to know is how does the temperature change in each of the layers. So looking at the troposphere, this goes from 0 sea level up to about 14 kilometers above the Earth's surface. And this is where 90% of all of your gases are. The troposphere is mostly made up of nitrogen and oxygen, with a little bit of water vapor and some carbon dioxide. This is where all of your clouds and weather occur. So when you look outside and you see clouds in the sky, you are seeing the troposphere. And again, temperature decreases as you raise higher. The next layer of the atmosphere is the stratosphere. The stratosphere extends from about 14 kilometers above the Earth's surface to about 50 kilometers above the Earth's surface. This is where the ozone layer is. You've probably heard a lot about the ozone layer in the past and the fact that we have holes in the ozone layer which are allowing ultraviolet sunlight to come in. In the areas where the ozone is solid, it is trapping the sun's rays, some of the sun's rays from coming in. And it is also the area of the jet streams. We will talk more about jet streams later this week. The important thing about the stratosphere is that temperature increases as you go higher in the altitude. The next layer is the mesosphere. This extends from 50 kilometers above the Earth's surface to 80 kilometers. This is the area where your meteoroids are going to burn up and give you that effect of a shooting star. Just like the troposphere, temperature decreases as you rise higher. You decrease the higher you go in the atmosphere. The next layer is the thermosphere, and this is where you have temperature increases as you raise higher here. So this is about 80 kilometers to 600 kilometers above the Earth's surface. And this shows you a picture of the northern lights. The northern lights are a reflection of the light that's coming through by the different gases of that atmosphere. The last and final layer of the atmosphere is the exosphere. This is refers more than 600 kilometers above the Earth's surface. This is where the atmosphere meets outer space. So when you hear about the astronauts traveling to outer space, they must go greater than 600 kilometers above the Earth's surface before they are considered to be in outer space.